Welcome to COP 4610 Computer Operating Systems. This is Unit 1 and an introduction to operating system concepts. So today we're going to talk about what operating systems do and get to some definitions regarding operating systems. So what is an operating system? Well, clearly you can look at this. You use operating systems every day, and you can look at this little figure over here and see that the operating system is a software that goes in between the applications that run on a computer and the hardware. So what are the goals of an operating system? Well, the goal of an operating system, it really doesn't do anything on its own other than maybe some maintenance, but its goal is to execute the applications on the system, the user programs, to make solving problems easier, to make your computer system convenient to use, and to use the hardware and the resources in an efficient way. So what is a resource? Okay, well, before we even talk about what a resource is, let's talk about what operating systems do. An operating system is a manager, and it has to use all these resources in order to do its management. So what does that mean? Well, it means that it doesn't do managing from a different location with its own resources. It has to share the resources with all of the user processes in order to do the management. So when it needs to do some work and schedule processes or allocate memory or do any work, it needs to take away from the real work that's being done in order to complete that. And that's called overhead. So overhead happens because the operating system has to take away the resources from the processes and use them in order to manage. So what do operating systems do? Well, from a user, the operating system just hides how everything's being done and makes everything work very smoothly. From the system point of view, the operating system allocates the resources. So let's talk about what a resource is. Here are some definitions: resource, process, deadlock, buffer, and cache. A resource is a component a component in anything, but for our purposes in operating systems, it's a component of limited availability that is necessary for effective operation. So a resource is whatever any process needs to use to complete its tasks. Memory, CPU, files, data, anything that's needed to complete tasks. A process, you might think, is a program in execution, but as you'll find as we go through the lessons in this course, you will find that if you only have one CPU, then only one process can actually be executing at a time. So a process is actually an active program. And what do you think a deadlock is? Well, a deadlock is a situation in which two or more processes are waiting for each other, and none of them are moving forward because they're all stuck waiting for each other. And we will have a whole chapter on deadlocks later in the semester. A buffer is an area of memory that stores data. So a buffer can store any kind of information between two processes or between a process and a device, but a buffer is just an area of memory where data is stored. And this data may be the only copy of that data. And a buffer is usually volatile storage, which means that that copy of that data could be lost if the computer is turned off. A cache is an area of very fast memory that is associated with your processor that stores copies of data. So a lot of times things get cached and they put in the cache for faster reference, but then you have cache coherency problems because you want to make sure that you're always working with the most up-to-date information. So what is the difference between a buffer and a cache? They both store data, but a buffer has the only copy of the data, and a cache, there might be another copy somewhere else, and a cache is also designed to be much faster than just a buffer that's storing information. So a couple more definitions. The kernel. The kernel of the operating system is the one process that is not actually running all the time, but is active all the time. So when your computer system gets started, the kernel, the core of the operating system, also gets started and gets ready. And some operating systems, depending on how the operating system has been structured, the kernel may be very small, or it may be very large because the operating system is dedicated to do a lot of things. And these are some of the information we will be talking about throughout the semester. So everything else that runs on your system is either comes with the operating system as a process or an extra program, or is an application program. An interrupt. Let's talk a little bit about interrupts. An interrupt is just a change in flow of execution. So if a process is executing and it has to stop, an interrupt happens. And the operating system needs to deal with interrupts because it may be interrupted in the middle of doing something, and there has to be handlers that handle all of these interrupts. Most modern operating systems are interrupt driven. What that means is most modern operating systems, like on your personal computer, they wait for someone to type in a command or click a mouse or start something in order to handle what they're going to do. So most of the time, everything happens in operating systems happens because of an interrupt. Not everything, but most activities. Some of the activities happen while the operating system is checking for things, but most of the time it just sits there waiting, and then it handles interrupts. And you should be familiar with the different types of storage. There's volatile storage, which you lose if the computer turns off, and there's persistent or non-volatile storage, which is maintained like on your hard disk or your anything that is you don't lose when the computer is turned off. So this is just a little overview of how a computer system is organized. And you have your CPUs, and everything is competing. Whatever you want to do needs to be put into memory, and then it is moved, and instructions are handled by your CPU. So you have all of your devices and your CPU that are executing concurrently. And you have controllers for your devices, which are some of your devices come with their own controllers. And the devices have their own local buffers, and your CPU will move data to and from main memory and to and from the buffers. And your input and output is from a device to a local buffer of a controller. And everything happens and causes interrupts, and the operating system deals with these interrupts and has to manage all of these resources and all of these resources for all of these processes. So again, like I said, it's interrupt driven. So what happens when an interrupt, the control goes to an interrupt service routine. And then the important part about it is that when an interrupt happens, the operating system needs to save the current instruction, so when it loads again, it will load where it was interrupted and not have to restart at the beginning. But in order to do that, the operating system has to use the resources, and that's called overhead. So when an operating system is performing its management tasks and using the taking away from the resources, that's called overhead. So we did a little introduction into some definitions, and read the notes, and thank you very much. And in part 2 of Unit 1, we will go through some more of the beginning operating system concepts.